Hello, my name is Matthew Newland, and for this video for homework assignment 2, we'll be using Cardano's formula to write a Python function to calculate the specific volumes P and T, or pressure and temperature values, for the SRK equation of state. Starting off, we will start writing our functions in code on the same code we used for our part 3 video, or for video for part 3. So we will split the screen, and from here we will use this sheet, or cubic equation sheet, that we have on our GitHub site, and we'll be using this. Just a refresher, our Cardano equation is this cubic function right here for x cubed plus ax squared plus bx plus c. We'll be basically using this as our main focal point. And what we want to do first is find our cubic roots of this function. So first we need, in order to compute a, b, and c, we first need to, with our coefficients a, b, and c, we can first compute this q value and r value. So we'll define this as such. We'll define cubic roots. We'll just set that as an r value and do a, b, c. And there we will set our q value as, since we need to encase this all and divide it by 9, we would do a squared minus our b value, or 3 times b, and then have that whole equation divided by 9. Our r value will be equal to this whole equation up here. So we'll start with multiplying out our a value. Since we need to cube this, we'll put that a value in its own parentheses, just to separate it off so it's not getting multiplied by 2 first. We will then close it off and then minus our 9 times a times b value, not capital B, and then we will have our c value getting multiplied by 27, and close off this entire situation, or close off this entire function or equation, and divide it by 54. However, there's a second part that we must be aware of when computing roots for the Cardano equation. It's this little thing here where we need our r squared value, and it has to be less than our q cubed value. So we must make an if-then statement, or an if-else statement, in order to compute the correct values, just in case if our r value is greater or less than our q value. So we will start by making the first portion of our if-else statement, and then we'll input our theta value. So theta will then equal our numpy function of our cosine. Put that in, and then have our excuse me, my cursor fell off. And then we'll have our q value be put to the 1.5 power, and then put that enclose that entire argument within our cosine, and then we will start to compute our roots. And these are our roots here, and since some of these have similar functions, or at least similar portions of each, we're actually going to separate a portion of these, more particularly to be, we're going to separate a portion of each equation off. More particularly, we're going to separate everything within our parentheses off, and put that into an array, so we can use that to calculate even more, or calculate the rest of our roots. From here, we will then start off by having our -2 values multiplied by our q values, which will be q to the square root 0.5, and then we will have a numpy function called NP cosine. And this is where the start of our array comes. So we will then put our first root, which would be theta over 3, and we'll separate it off. And then our next section will be theta plus 2 times our numpy function of pi, so it would be np pi. That will be separated off, divided by 3. And since our third value here for our root is the same thing as our second one, except this plus is now turned into a minus. So we'll copy and paste that over and switch those values. From there, we'll close off our array, close off our cosine function, and then we will finish off the rest of this value by having AB divided by 3. And from there, we have our roots function. So let me press return. And now here comes the tricky part, is getting the rest of our functions down. Because if you notice here that our A values here are a bit iffy. We have 2 more if else statements we need to compute. Our A value, which we can put immediately, but one other thing we must do, or actually, sorry, we must return our roots value with our NP sort, with a numpy sort function. And this will sort the array we made above to make sure that everything up here is, make sure this this array is in proper order. So we'll put NP sort, and then we will continue on to the rest of our code. So our next else statement is A, and since we want to copy this one down, it's going to be negative NP sine. And the sine value, or the sine function for numpy, more just indicates what sign R is going to come out as. If R is a positive value, it will spit out a positive one. If it's negative, it will spit out a negative one. So that is what we want to do here. And then we will then compute the rest of this function here, or this equation here. So first, we need to put our numpy function of absolute value of R in. So we will then have our R plus our, have a big old equation here to make sure everything's sitting within the function. So we will have our R squared plus our Q cubed, and we'll close off this whole function and have the next portion of our function be set to our square root. So we multiply that at 0.5. We'll keep that in parentheses just to reduce errors. So then we close off that function, and then we will close off, our next we want to do is then we want to put one more power situation into there, which will be 1.3, and close off the rest of that situation out. And this should be our function that is ready to go here. Actually, just in case if this wants to be a little finicky, I'm gonna just have this whole function be multiplied out by our 1/3 value. So next, since this first function, since our b is 0, we want to put this, our b is 0, if, and this will then have our next if statement be put in. We want to put a equals 0, and we're going to use 2 equal signs because we're not setting a as a value of something. We're more doing it as if that expression is true or not. So we're going to put the rest of our else statement out. And then we're going to make that q over a, which is our a. If a is not equal to our value, we'll put that there. And then we're going to return the rest of this value. We're going to return this value as a plus b minus a over 3. And let me just do a quick check over, make sure everything looks fine. I believe we should be good to go. So we'll see if we get any errors, and that's good. So from here, we want to find our cubic functions for our SRK equation of state. And first we will set our cubic volume function, and what we're going to take, and since we have our pressure and temperature values, we can put that in. We want to set those immediately off. And one thing we're going to do is we're going to come back up and we're going to take our cubic coefficients equation here and bring it back down. Actually, let me go back up and grab this whole function instead of not including the t, just for the sake of not making errors. So we will unpack our b, epsilon, and sigma values and set that equal to our function of cubic c, or our cubic coefficients. Next, what we want to do is we want to go back to the very beginning, before we started doing Python for this homework assignment, is that we're going to start using these roots here. Since z cubed doesn't have any more roots attached to it, we're not going to include that in the final product. So then we're going to need all of these values here. So we can split this off and just have it up. But first, before we get to that, we need to set our beta and q values that we received from our original function. So